Today's discussion is about transportation problem and assignment problem. This is the transportation model. There are M sources and N destinations, and the cost, transportation cost, the unit transportation cost of transporting 1 unit of the item from O1 to D1 is C11. The cost matrix is given, and these are the availabilities and these are the requirements. This transportation table is said to be balanced if summation over I AI is equal to summation over j bj. And to find the initial solution for this transportation problem, we have northwest corner rule, row minima method, column minima method, matrix minima method or least cost method, matrix minima method, which is otherwise called least cost method, and the last one is Vogel's approximation method. And to find the optimum solution, you use Modi method. Right. Now, in the assignment problem, the problem is to minimize the assignment cost. Right. Some n jobs are there, which can be processed in n machines, n different machines. The costs are given. Here, under each type J1, only one job is there. So, the main difference between under each type, only one machine is there. The main difference between the transportation problem and the assignment problem is that the availability are positive quantities. Here they are equal to 1. The requirements are also any positive quantity, integer quantity. Here they are all equal to 1. The rim requirements are all equal to 1. That's the main difference. Okay. And since this is the case, the number allocated in assignment problem will be either 1 or 0. Apart from that, you will not have any other values for the decision variables. That is also the difference. And here again, the objective is to minimize the total cost. Right? Now with this idea, let us discuss some of the questions. In transportation problem, the objective is to minimize the transportation cost, minimization type. In a transportation problem with M sources and N destinations, the number of constraints is equal to, see, for each row you have a constraint that summation of this xij variables is equal to A1. Here it should be equal to A2. Here the total of all the variables should be AN. And here B1, B2, Bn. So you have on the whole M plus N constraints. Okay. The number of constraints with M sources and N destinations are M plus N. The necessary and sufficient condition for the existence of feasible solution to your transportation problem is that the problem should be balanced. That is, summation EI is equal to summation over J, summation over I AI is equal to summation over J Bj. All the constraints of a transportation problem are equations. They are not inequalities. All the constraints are equations. Right? The solution to a transportation problem is degenerate if the number of basic variables is less than m plus n minus 1. The number of basic variables should be equal to m plus n minus 1. If it is less than m plus n minus 1, it is a degenerate solution wherein you will introduce an artificial allocation by allocating a quantity epsilon while applying Modi method. Okay. To apply Modi method, the initial solution of a transportation problem should be a non-degenerate solution. That is, you should have allocation in m plus n minus 1 cells. Then it is a non-degenerate solution. If any of the cell is 0, the number of allocations will be less than m plus n minus 1, in which case it is a degenerate solution. You cannot proceed with the Modi method. So you can apply Modi method only when you have a non-degenerate basic feasible solution. The objective function of an assignment problem is of minimization type. The values of the decision variables in an assignment problem can be 0 or 1. Right? You cannot have any other quantity which is greater than or equal to 0 because all the rim requirements are equal to 1. On the whole, when you add all the decision variables x11, x12, etc., x1n in the first row, the total should be equal to 1. So in that case, the value of the decision variable can be 1 or 0, right? You cannot assign any fractional quantity. An assignment problem is balanced if the number of rows is equal to the number of columns. An assignment problem is the dash of transportation problem, a degenerate form of transportation problem, right? An assignment problem is a degenerate problem of transportation problem. Degenerate form, okay? The assignment algorithm is also called as Modi-Johnson's Hungarian approximation, Hungarian method. To convert unbalanced assignment problem into a balanced assignment problem, introduce rows if the number of columns is less. No, this is wrong. If the number of columns is less, you should introduce columns, okay? Introduce columns if the number of rows is less. This is also wrong. Introduce row or column, whichever is less. If rows are less, introduce rows. If columns are less, introduce columns. So this is the correct answer. The solution to the transportation problem is optimum if all ui plus vj minus cij are less than or equal to 0. In an assignment problem of maximization type, the type of matrix is maximization type. Cost should be minimized, loss should be minimized. So profit matrix is the correct answer. While moving to a next iteration using Hungarian algorithm, the number of lines drawn covering all the zeros should be minimum. You should draw minimum number of lines covering all the zeros. The number of lines should be minimum. Okay.